Section 2.4, we're looking at the derivatives of trig functions. So first, let's remember what sine function is. Sine starts at 0. Starts at 0. And then pi halves is at 1, and then pi back to 0, then negative 1, then back to 0. Alright, so here's what it kind of looks like, the graph. So there's sine. So if we're asked to graph the derivative, my x's would stay the same, but my y values are the slopes, right? So here we have a horizontal tangent, so that means my slope would be 0, so my derivative is 0 at pi halves. Here at 3 halves pi, my horizontal tangent is also has a slope of 0, and so there's the 0 there as well. And then we can see that from x of 0 to pi halves that our slope is going upwards, so that means this is above the x-axis, so we're up here between 0 and pi halves, we're above 0, so we're somewhere up here. And then after pi halves, we're going down, the slope's going down, so that's negative. So that means right here at pi halves, we're switching from positive to negative. So my graph is going down from positive to negative. So it might look something like this. It's positive, and now I'm coming into the negatives. And then right here, it's still negative slope, negative slope, negative slope. We're still negative here up until this point right here, and then we go back to positive, right? So I want to be negative, and then right here I'm going to switch at 3 pi halves back to positive, and then I'm positive, positive, positive slope. So that's why I'm above the x-axis. So there's kind of my graph. It's probably not going to go that far. There's kind of my graph of my derivative of the sine function, which looks very similar to, what function does that look similar to? It looks something like that. Probably went a little high. That looks similar, there we go. That looks similar to cosine, because doesn't cosine go 1, 0, negative 1, 0, back to 1? So the derivative of sine is cosine. And we can go ahead and prove that by taking the limit of the difference quotient. So that'd be sine, let me move over here, sine of x plus h minus sine of x all over h. So remember, I had to simplify this in order to get an h out, so that h can cancel, and then I can go ahead and put the limit as h goes to 0. So if we remember our stories from Sinbad and Cosette, when Sinbad goes on a date, he goes out with Cosette and says their signs are the same, and makes his brother hang out with her sister. So there we go. X in here, and then minus sine x all over h. So then we can go ahead, separate this into 2 separate fractions. And we'll go ahead and put our sine x's together. So let me erase this, sine x. So negative sine x, because then we can factor out a sine x. So that's 1 fraction. And then plus sine h of cosine x all over h. And so we just separate, instead of 1 fraction, into 2. So then we go ahead and factor out that sine. On this one, the sine x, I get left with cosine h minus 1. And I can rewrite this as just multiplied, because it's a product there. So I can do that, right? Because if I just put 1 over here, then it's all over h. So I can separate that to a fraction times a whole number kind of thing. And then this, I can do the same. Sine h over cosine x over, let's switch that. Let's do cosine x over sine, because in this section there's a couple limit equations that they give us. One is that we have something like this, sine of h over h, so when this angle is the same, so when you're taking sine of an angle divided by the same angle, then you can go ahead and take the limit of that, and the limit of that, so the limit as h goes to 0 of sine of h over h equals 0. So we're going to use this definition in here. So we're going to use that, and we're going to plug that in right here. So this would be 0. And then anything times 0 is going to, oh, sorry, that doesn't equal 0. That equals 1. Check my formulas. That equals 1, so this is just cosine of x. So now I got rid of that h, right? And now I still have this one. Well, there's another formula that will deal with this. And it says the limit as h goes to 0 of cosine of h minus 1, which we have, cosine of h minus 1, all over that same angle. That goes to 0. This is the one that went to 0. So we're going to enter that one in right here. So that's 0. And 0 times sine of x is 0. So then we get 0 plus cosine equals cosine of x. So there we go. So that's our derivative, is cosine of x. So these are the formulas that I used. So the limit as our angle goes to 0 of sine of that angle divided by that same angle equals 1, where cosine of that angle minus 1 over that same angle equals 0. And then we can also prove that the derivative of cosine, kind of in the same way, is minus sine of x. So the derivative of cosine is minus sine of x. You can see that from the graph, as well as a proof that. So the rest of these derivatives you want to get, so there's sine and cosine. They're on page 144. So you want to have these down, and this is what will be one of your projects, is to create a poster containing all of these. So they're on page 144, or the rest of the trig derivatives. Okay, so I'll go ahead and do a couple of these. Here we can use the power rule, so taking the derivative of y prime, 12x to the third, drop a power. This is sine times, or 7 times the derivative of cosine. So the derivative, that's d over dx, means the derivative of cosine, so I got to find that, which you look is negative sine. We can times that by 7, so we get negative 7 sine x, and then we have our 12x cubed. So that is y prime. Y prime, you can say that, or you can say the derivative of y, or you can say dy over dx. Any of these three would kind of be the same. Okay, here's the product rule. So here we have multiplication here, so that's the product, right? So derivative of the first, so this is my f. Sometimes it's good to label, and this is my g. So you could just say f equals 3x squared, g equals tan x. Then I can go ahead and take this, so the derivative of f is 6x, where the derivative of g, I look at page 144, and it tells me that that is secant squared x. And so now I can put it into this kind of formula for the derivative of f times g. So the derivative of f times g. So that's f prime. A lot of times I like to actually put the g first, but this one it's probably better to put this first because tangent comes after. So then you know you're taking tangent of x and then multiplying it by 6x. And then g, so this one I would put f first, just because it looks better. And g prime is secant squared x. And so that's the derivative, y prime or dy over dx. Okay, here's the quotient rule. So we got the quotient rule here. So again, you can label this as f, this is g. And so f equals cosine of x. So f prime is negative sine x. G is 1 minus sine x. And so g prime will be taking the derivative of 1, which is just 0, and the derivative of sine, which is cosine, so we get negative cosine x. So g prime equals negative cosine x. And then g squared would equal 1 minus sine x squared. So then you write f prime times g. So this one, you probably, doesn't matter again, kind of which one goes first. So that's a negative sine x, and then minus g prime, which is negative cosine. So that would make this a positive, because it's a negative here and a negative here is positive. Positive cosine x, and then times f, which is another cosine of x. So really you get 2 cosines of x all over g squared, 1 minus sine x squared. So then you could simplify, it would be negative sine x plus sine squared x plus 2, or not 2, cosine squared x over 1 minus sine x squared. So then this, if you remember from your Pythagorean theorems, that equals 1. So we have minus sine x plus 1, which is the same as 1 minus sine, over 1 minus sine x squared. So that's going to cancel with one of those. So we get 1 over 1 minus sine x. Okay, here's the special limits that I talked about. I talked about this one and this one. And so here we have a couple examples of doing this one. So what I want to turn this into is I want to turn it into the same. These need to be the exact same. So one way that I can treat this is I can just take this top one, sine over 4x, and turn that into this. So in order to do that, I would need to have over 4x, right? Because then that would turn to 1. Well, if I divide that by 4, that means I also have to multiply that by 4. And so I still have my over 5x here. That's fine. So now I can take this one, because I really, in essence, I just multiplied the top by 1, which is fine, because multiplying the top by 1 is not going to change the top. And so now that will become 1, and 1 times 4x over 5x equals 4x over 5x, which equals 4 over 5. So the answer to this would be 4 over 5. Okay, you can kind of do the same thing a little bit on this, just a little bit different. So we still want to make it the same as this one up here, okay? So we need a cosine minus 1. Well, we have a 2 cosine minus 2, so if we just factor out a 2, we get cosine x minus 1 all over x. And so now it's the same. And so now this part will equal 0. And we have 2 times 0, which equals 0. So the limit of that is equal to 0. So that is using those special limits.